All right, so welcome back to the Civil FE exam review. Today in this video, we're going to be finishing up our geotechnical engineering section. We're going to be focusing specifically on the last topic, which is a soil stabilization. If you have not checked out the videos leading up to this part K, then definitely check out those videos because they're very in depth and go through foundations, bearing capacities, all of this stuff. So, all right, so let's go through these practice problems for soil stabilization. All right, so number one says, how does the addition of lime as a soil stabilizer contribute to improving soil properties in construction? Okay, so first things first, we want to write anything that we're given. We know we're dealing with lime here. As a soil stabilizer contributing to improving. So how does it improve soil properties? How does lime improve soil properties? Okay, so are there any formulas needed? No, not applicable, but you do need some prior knowledge, right? Some PK. Okay, so what prior knowledge might you need? Okay, so lime, I'm gonna go through what lime does. So lime can help in it aids in the drying of wet or saturated soils by facilitating drainage and reducing water content. Okay, so lime also can contribute to the detoxification of certain types of expansive or reactive clay minerals, right? So this will prevent undesirable soil reactions, right? So there's some other things that it can do, but that's kind of one of the top ones. So it can be or help in the reduction in plasticity. So lime treatment reduces the plasticity index of clay soils, making it less susceptible to volume changes. So you don't want your soil moving and changing volume drastically, because you got to think, let's say you have this that's the ground, right? And in one image, the ground volume is like that, right? It's all filled in. You're all good to go, right? Okay. Versus another soil where the volume is like the first, or it's like this one, the first image, but over time, it does like this, right? Let's say that is what happens, all right? The volume decides to change, all right? Well, what do you think is going to happen to the ground? The ground is going to tilt or collapse, right? It's going to come down, all right? Gravity has a way of, or it's going to start to rupture up. So you don't want that happening, right? So if you're able to keep the ground from changing volumes, then that's ideal, right? So it reduces the plasticity. Yes. So let's go through our choices and see which one makes the most sense. So A, by increasing soil plasticity. No. All right. It decreases the soil plasticity so that the volume doesn't change. B, by reducing soil strength. That doesn't improve properties by any means. Right. Through a chemical reaction with coarse aggregates. No. Or by detoxifying or by promoting drainage and detoxifying the soil. So yes, it's gonna be D. So it can contribute again to the detoxifications of certain types of expansive or reactive clay minerals, preventing undesirable soil reactions, right? So something about lime. I didn't know that about lime, so I did research on that. When I dealt with lime, I typically dealt with it out in the field where you would pour concrete, or concrete was being poured. And if I was testing the concrete and its specifications, like for a slump test, you're testing how, liquidy it is. And so for some of those tests, you would have this thing called a slump cone. And then that slump cone, when concrete goes in there, it's not going to stay clean, right? So typically, concrete forms, you're rinsing it out in the field after you've done your test, but you want to get that concrete off of your slump cone so that you can measure how liquidy it is on your next test. Well, in order to do that, to keep your slump cone clean, sometimes what we would do is we would spray our slump cones with lime, and that would basically allow the concrete to be a little bit more, it would do something to create the concrete to harden up in certain areas, but it was like a oil almost, where it would make whatever was on our slump cone disassociate from the concrete, separating the two, so that we could scrub it off and get rid of the excess concrete. So lime is very powerful stuff. Very cool to know that it can also help with soils as well. So, all right, let's look at number 2. All right, number 2. How do geogrids contribute to soil stabilization in the construction of highway embankment over soft compressible clay? Okay, so what's our given information? All right, well, we know we're dealing with geogrids. That's about it. There's no variables or anything. So geogrids. Okay. Find. What are we trying to find? How geogrids contribute to soil stabilization, right? So how does it contribute? How does geogrids contribute to the soil stabilization? Okay, so what formulas are needed? None, but you need some prior knowledge. All right, so the prior knowledge that you may need, all right, is that GeoGrid is basically, it helps with reinforcement. So tensile strength enhancement is one of the first things that it can do. GeoGrids are categorized by high tensile strength in both the longitudinal and transverse. So that's just the horizontal and vertical directions. When placed within, when you place geogrids within soft clays, these geosynthetic materials act as reinforcement element. So let me show you what a geogrid looks like. So imagine this being a top view. So you'll have your soil on the ground. Okay, that's my soil layer. And then I'll have this geosynthetic grid or geogrid on top, right? And it won't look like that. I'm sorry. It won't have the holes. It will have holes, but basically it will have individual rectangles. And so what's happening is this is the grid that is created, right? And if you can see, in these little grids, right? And I'm gonna color each grid in green, right? I won't color each one, but that's a grid, that's a grid. In these pockets is where the soil goes, right? So you had your bottom, but then you lay your grid out on top of that layer, and then you put your grid down, and then on the next layer you start filling your grid with soil. So that's what this green is showing. And so anywhere in between these grids is, the grid is flat. So up above it, right, it's going to be pressing down and creating some tension. Soil is going to be creating tension, and the soil in between these little grid areas are going to be stuck, ultimately creating more strength for the soil. So I hope that made sense. May not have, but hopefully that gives you a little bit better of a visual of what's happening. All right. So it helps with tensile strength enhancement. It also helps with load distribution, right? Geogrids help distribute applied loads more evenly across the embankment. In soft clay, traditional embankments may experience a differential settlement due to non-uniform nature of soil. So geogrids can counteract this by spreading the loads and reducing localized stress. So in these little grids, those pockets of soil can be a little bit more compact, strengthened. And so now when you lay a load on top of the soil after that, then its foundation should be a lot stronger. So based on this information, let's choose an answer. So how do geogrids contribute to soil stabilization over compressible clay? By increasing the plasticity of the clay? No, if you do that, that's going to make the volume of the soil vary a lot, causing there to be problems within the foundation. So no. By decreasing the tensile strength, no, you want to create tension in those little pockets of soil, because that's gonna allow the load distribution to be a lot better. And we want to stabilize the soil, right? So through a confinement effect, distributing loads and reducing localized stress. Okay, so yes, we're confining our soils. We're evenly distributing the loads, are helping distribute the loads a little bit better, and reducing the localized stress. So yes. And then D was by promoting creep deformation in the soil. That sounds horrible. Sounds creepy and not good, especially for deformation. So no. Answer is C. Alrighty, so let's look at number 3. All right. So number 3 says, how does the use of fly ash contribute to mitigating the swell potential of expansive clay and stabilizing the soil? Okay. So we're given fly ash, right? And we want to find how the use of fly ash contributes to mitigating the swell potential of expansive. Okay, so we just want to figure out how it keeps it from swelling. How fly ash keeps clays from swelling. All right, when clays swell and expand, anything that's above it is going to not know what to do. It's going to cause the foundation to pretty much get screwed up. So, yeah, there's going to be an imbalance, right? So you're going to need no formulas for this, but you're going to need some PK, prior knowledge. So a few things to note about fly ash. Fly ash contains pozzolanic materials that react with calcium hydroxide in expansive clays. So this forms a cementitious compound, right? So this reaction contributes to improved soil strength and reduces its susceptibility to swelling and shrinkage. So you don't want it to get big, don't want it to get small, right? All right. So that's the reaction that it creates with clay, right? It reduces the plasticity. So fly ash alters the plasticity characteristics of clay soil, reducing their plastic index. And this can make the soil less prone to volume changes, right? Don't want volume changes, which again minimizes the potential for swelling and shrinkage. So these are things that I researched, things that you do need to have some prior knowledge of how fly ash, these different materials can help with soil, right? Improved compaction, right? So the addition of fly ash enhances the compaction properties of expansive clay, right? So this improvement is crucial for achieving a more stable and resilient soil structure, which reduces the likelihood of settlement, right? All right. So based on that information, as we look, let's check out our answer choices. Okay, so A, by increasing soil plasticity. Well, we know if we increase soil plasticity, that messes with volume, which at the end of the day can create more swelling and shrinkage. Right, so no. By decreasing the soil permeability. So what is a permeability? So fly ash actually helps increase the permeability of clay soils. This is definitely beneficial for drainage, as it allows water to move freely through the soil, reducing the risk of water-induced swelling, right? So that is wrong. Right, we want to increase permeability, or the flow of water through your soils, right? If water needs to go to a certain part of the soil, it has the freedom to do that, right? With fly by having fly ash through a pozzolanic reaction that forms cementitious compounds. Yes. Remember, fly ash contains that pozzolanic materials that react with the calcium hydroxide in expansive clays, and this forms that compound, that cementitious compound. And by having this reaction, it contributes to improved soil strength. All right, imagine having cement compounds in your soil or in your clay soil, which can reduce how much that clay can swell and shrink. Right? Cement is probably going to be tougher than your clay, so just something to make note of. And the last one is by reducing the load bearing capacity of the soil. Absolutely not. That's not a good thing. If you reduce how much the soil can bear, that we want it to be as strong as possible, right? Okay, so C is our answer. So this concludes soil stabilization. You're using when you're dealing with soil stabilization, you're dealing with materials that can hopefully help the soil become more stable. So you can use things like lime, like fly ash, these different things to get you to that point. So that concludes the geotechnical engineering section. In the next section, we'll be looking at transportation engineering. So I'll see you in the next video.